So in the last lecture we discussed that we will solve the pulley system using the energy method. Let us see if it is working or not. Okay. So remember what was the acceleration of this pulley system? So the acceleration we found to be m2 minus m1 divided by m1 plus m2 g. Okay, this is what we found. Now this we did by using all this thing, using the energy and everything. Now what we'll do is we'll solve it without using the forces. We'll solve only using energy. So now consider the pulley again. Okay, and consider both the objects were initially at the same position. So consider we have the m1 here and m2 here. Okay, now assume that this position means that the potential is 0. Just assume that this position means the potential energy is 0. Obviously kinetic energy is also 0. So total energy of the system initially, so what is the initial? I means initial. I total energy is, so let me write total energy as E, which is 0, because the potential energy at that position is considered to be 0 and the kinetic energy is also 0. Now let us see what is the energy in the final state. Okay, now in the final state what will happen is, in the final state we will have this thing. Okay, this will be the final stage. So why I said this will be the final stage? Because you see, at this point somewhere around here, at this point the potential is 0. Okay, we assume that this is the line where the potential energy is 0. Now if you look at this diagram, you will see something interesting happening. You'll find that m1 has gone up and m2 has gone down. Say the height is height through which m1 has gone up is h dash, and the height through which m2 has gone down is h dash. Now we need to calculate the velocity. So we know through what height the mass has moved and what is the accelerations. How to calculate velocity? We know that v square equals to 2 into a into h dash. Okay, you all know this equation. So this is the velocity of both the masses if they have moved a distance h dash through an acceleration. That means what is the velocity of each of the object? The velocity of both the masses will be root over of 2a h dash. Agreed? That's part 1 of the theory. Now at this position something interesting is also there. At this position the mass have not only kinetic energy but also potential energy. Okay, now question is how to find it. So there is kinetic energy and there is potential energy. Now can you tell me what is the gain in potential energy? The gain in potential energy is m1 g h dash, because the object has moved up. Now can you tell me what is the gain in kinetic energy? It is half into m1 into v square. Agreed? Now at this point the mass m2 has also both the energies potential and kinetic. So the mass m2 has gone below the 0, so it has a loss in potential energy. So loss in potential energy is minus m2 g h dash. And what is the gain in kinetic energy? So the kinetic energy that it has achieved is half m v square. This m will be m2. So can you tell me what is the total energy of this system now? The total energy of the system is sum of all the energies. So add the energies of part mass 1. So you have m1 g h dash plus, so what is half m1 v square? What is v square? V square is, you can calculate v square from here. It is 2a h dash. So when you put v square here, you will get what? You'll get m1 a h dash. Agreed? So that you do it yourself. So what I can write in place of kinetic energy, I can write m1 g h dash. Now you add this, because this is, because the mass is, because the system means what? The system means both m1 and m2. So now the energies of m1 you have to add, but there is a minus sign here, so write it as minus m2 gh dash. Remember, we are adding both the energies. Okay, I'm just skipping one step, and this is half. So this can be also be written as m2 a h dash, m2 a h dash. Agreed? Now we know that total energy is conserved. So this is the final energy and this is the initial energy. So the both will be same. So by equating the initial total energy with the final total energy, what do you get? The initial total energy is 0 and the final total energy is this. So m1 g h dash plus the kinetic energy, which is m1 g, it will be a. Okay, just missed one step. This won't be g, this will be a. Okay, this is m1 a h dash. Okay, now the second part, that will be minus m2 g h dash, and there is a plus m2 a h dash. Now if you solve it to find a, okay, you can easily calculate a will be um, m2 minus m1 g. So m2 minus m1 g divided by m1 plus m2. Okay, so we are able to find the value of the acceleration with which the pulley will both the masses of the pulley will go up and down. That acceleration we calculated just by using the energy method. So you see, the amazing thing about energy method is, instead of using the force method, see, remember this, in the last equation, in the last basic classical mechanics, we solved the same by using forces. Tension is a force, mg is a force, ma is a force. We set up the equation using the forces. But now we set up the equation using the total energy, and we applied the law that total energy has to be always same, and then we came to the same conclusion of acceleration. Amazing, right? So an energy can solve the same problem that the force can solve. So both are different approaches, but they will give you the same answer. Let me repeat again. The energy approach to solve the problem and the force approach to solve the problem are both different approach, but they will give the same answer. However, the energy approach to solve problems is usually easier than the forces. So whenever you look at a classical problem, try to always think, is there a energy way of solving the problem? This is the trick to solve classical mechanics easily. So why I have taught you energy? Because in the next class, when we will discuss about the Lagrangian mechanics, this energy will play the fundamental role in the Lagrangian mechanics. That we'll discuss in our next lecture.